Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to graph quadratic inequalities in general form. Alright, let's start out by writing down the instructions for the question. We are to graph the given inequality and verify the graph with a graphing utility. Okay, we're going to be using a calculator to verify the accuracy of our graphs, and we'll also make use of Desmos, a computer-based graphing program. So for problem 1, let's say we have the quadratic inequality y is less than 2x squared plus 6x minus 1. Alright, let's go ahead and take a look at the steps for the problem solving process. There are going to be 3 steps that we're going to follow to generate the graph of this quadratic inequality. Step 1, we are going to find the vertex. We're not completing the square here. We're going to use the formula for determining the vertex of quadratics in general form. After that, we are going to find the y-intercept, and then we'll use the symmetry of the graph of a parabola to graph another point. And then finally, we're going to graph the function and apply effects. Okay? What do I mean by the application of effects? Well, when you're graphing an inequality, you might have a solid or a broken line, and then shading is involved in the process. Okay, so we're going to graph the line and then apply the appropriate effects to the line and then shade afterwards. Let's start with step 1, which is the determination of the vertex. The vertex, x and y vertex, can be found using the following formula. As you might already know, you can use completing the square to express this quadratic in vertex format and easily determine the vertex from there. But you can use the following formula to find the vertex directly. Okay, so it's negative b over 2a for the x coordinate of the vertex, and then f of negative b over 2a for the y coordinate of the vertex. Okay. We're going to need a, b, and c to find the vertex and the y-intercept. So let's determine what a, b, and c are. So you remember the general form of a quadratic equation is ax squared plus bx plus c equals 0. So the coefficient of x squared is a, the coefficient of x is b, and then the constant is c. Okay, so here we have a is 2, because that's the coefficient of x squared. B is 6, that's the coefficient of x. And then the constant c is negative 1. Alright, let's find the x coordinate of the vertex. So what's the formula for the x coordinate of the vertex? As you can see, the x coordinate of the vertex is negative b over 2a. So we have negative b over 2a. Now we're going to substitute the a and b values. So we have negative 6 divided by 2a, 2 times 2. Let's go ahead and simplify this. We'll have negative 6 divided by 4. Now this can be reduced. The greatest common factor of 6 and 4 is 2. So we divide numerator and denominator by the greatest common factor, and that yields negative 3 over 2. Or you can write this as a fraction format, which is negative 1.5. Okay? There goes the x coordinate of our vertex. Now we're going to proceed to determine the y coordinates of our vertex. The y coordinate of the vertex can be determined by using the formula f of negative b over 2a. Now what does this mean? It means we're going to plug in the negative b over 2a value, negative 3 over 2, into the function. Okay, so we're going to have f of, let's switch colors here, negative 3 over 2 is what we're going to evaluate. Alright, so we know y is equal to f of x. This is the function up here. So we're going to input negative 3 over 2 into all the x's in this function. So we're going to have 2 times, instead of x, we replace it with negative 3 over 2 square, plus 6 times, instead of x, we replace it with negative 3 over 2. Close that. Minus 1. Now we are going to use the order of operations to simplify this expression to the right. So we'll have 2. Negative 3 over 2 square basically involves multiplying negative 3 over 2 by itself. If you square negative, it becomes positive. If you square the 3 times 3, that gives you 9. And if you square 2, that gives you 4. Okay, so we have 2 times 9 over 4. This can be written as 2 over 1 times 9 over 4. And then express this as 6 over 1. Plus times minus is minus. 6 times 3 is 18 divided by 2. Minus 1. Now, let's see what we can do here. If we look at the first fraction, we can reduce that. 2 goes here 1, 2 goes here twice. So we now have 9 over 2 minus 18 over 2 minus 1. Now when you're adding or subtracting fractions, the denominators must be identical. The first two fractions have identical denominators. We need to work on this constant, negative 1, by expressing it as 1 over 1. Now we'll multiply this by 2, top and bottom. And we're now going to have negative 9 over 2 minus 18 over 2 minus 2 over 2. Alright, for the first two, 9 minus 18, that gives us negative 9 over 2 minus 2 over 2. Negative 9 minus 2 is negative 11 over 2. Okay, so that's the y coordinate of our vertex, which is the same thing as negative 5.5. Okay, so let's write down our vertex. Our vertex for this problem is the x coordinate, negative 3 over 2, and the y coordinate, negative 11 over 2, using improper fraction or using decimals, negative 1.5, comma, negative 5.5. Alright, so if we go back to our steps, step number 2 involves finding the y-intercept. So let's do that for part 2. We're going to find the y-intercept. The y-intercept is simply your c value. Okay, whatever the c value is, when you have your quadratic in general form, that's your y-intercept. Okay, so y-intercept is equal to, if you go back up to where we started, we ascertained that the c value is negative 1, ABCC is negative 1, so our y-intercept is going to be negative 1 also. Alrighty, now let's go on to the part where we're going to graph. Okay, so we're going to graph the quadratic inequality and apply the effects on the line. Now let's take a look at a real quick matrix that helps us to identify the exact effects to apply to the graph of a quadratic inequality based on the inequality symbol. Alrighty. So let's say we have the four main inequalities that we're going to be looking at in this unit. You either have less than or equal to. You have greater than or equal to. Now, if your inequality is less than or equal to, you're going to shade downwards, shade underneath the vertex and around the region of the parabolic function that's underneath the vertex. Okay. If you have greater than or equal to, you're going to shade in the direction above the vertex and every region in that area above the vertex. Now, if you have less than or greater than, your line will be broken because it does not include the line. If you have less than or equal to or greater than or equal to, in this case your line will be solid because of that inclusion component of the inequality symbol. Okay. Alright, let's go ahead and graph the line. The function we're dealing with is y is less than 2x squared plus 6x minus 1. The inequality under consideration is less than. So what does that tell us? We're looking at this case right here. No, not that one. This case right here, which means we're going to shade down and the line is going to be broken. Okay? So shade down and broken. Alright, let's go ahead and apply all the information we have now on our graph. We have negative 1.5 and negative 5.5 as our vertex. So we know it's going to be centered in the third quadrant. Alright, let's go ahead and calibrate our graph. Let's call this 0.5, that's 1, 0.5, that's 2, 0.5, that's 3. So this is negative 1, negative 2, negative 3. And then for the y, 0.5, that's negative 1, 0.5, 2, negative 2, 0.5, negative 3, 0.5, negative 4, 0.5, negative 5, and then negative 5.5 right here. Okay, so this is our y-axis, this is our x-axis. Let's start by graphing the vertex. The vertex is negative 1.5, comma negative 5.5. So it's going to be right here because you have negative 1.5 and negative 5.5. Our y-intercept is negative 1. So it's going to intersect at this point. So it's 3 boxes to the right. This is the axis of symmetry. So using the symmetric nature of the quadratic function about the vertex, we can also go 1, 2, 3 to the left to find another point that's on the graph of the quadratic. Okay, so now we're going to connect the dots using a broken line. So let's sketch our broken parabolic curve. Dotted, dot, let's curve it, dot, 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 past the y-intercept, and then the other one, dot, 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 right there, and through the other point as a mirror of the y-intercept. And there goes your quadratic inequality, but we're going to shade, this is the vertex, right? So we have less than, that means we're going to shade underneath and around. Okay, so in this direction, that's the direction that we are shading for this quadratic inequality. Okay, so have it looking like that and like that, all the region on the outside, because that's where the bottom of the vertex lies. Okay, so there goes the graph of your quadratic inequality. Now let's go ahead and verify our result using the graphing calculator. So turn it on, you go to the y window, 2x caret 2, raises it to the second power, plus 6x minus 1. Since we're shading the bottom, you go to the line style, hit enter. That's a solid line. Enter again. That's shade the top, which is for greater. Hit it again. That's shade the bottom, which is for less, what we desire. Okay. If you hit graph, there goes your quadratic inequality. Okay, we're also going to graph the same inequality using a computer-based graphing program known as Desmos. So if you go to desmos.com, you can take advantage of this great graphing software. You can also download it on your mobile device for use where you do not have internet connectivity. Okay, so hit start graphing, and then all you simply do is type in the quadratic inequality as was presented in the problem. Y is less than 2x raised to the second power plus 6x minus 1. And there you have it. The nice thing about this is that it's interactive. You can click on the point. You see that's the vertex, negative 1.5, negative 5.5. That agrees with what we found earlier here. Negative 1.5 and negative 5.5. And then we also ascertain that the y-intercept was 0, negative 1 as reflected here. And then if you mirror it, you hit the other point over there also. Okay, so this clearly shows that our graphical result is in fact correct. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of quadratic functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial or any Algebra 2 Common Core questions in general, just place your question in the comment section below and we will be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.